Okay, welcome back to Ox Tools. I'm Tom. The last episode of this heavy-duty steady rest, we were working on the upper section here. We did a bunch of work on that. We cut the groove for the roller guide on two sides, and so now we're going to do the same thing on the lower section here. So we have to cut grooves through here and through here. And these are the lower two roller rests. So the interesting part about this is they're at an angle. So the steady rest in operation kind of sits like that, but these come in at this, whatever that is, 30-degree angle to support the bottom of the shaft. So we've got a couple of datums here, the split line here between the two halves, and then the bottom that interfaces with the ways on the lathe. But so this is kind of I call this a fun setup job because you get to think a little bit and how you can attack it. So what I want to do here is I want to set this at an accurate angle here, and then cut these grooves. Cut these grooves parallel with the machine axis. So, and have a repeatable angle on those. So then I got one here, and then on the opposite side I have to cut 4 grooves total. So let's go ahead and get this set up. I was thinking about it off camera how I wanted to do it, and so let's go ahead and get right into it. So what I'm going to do here is I have these aluminum bars here that I made a long time ago, and these are counterbored on the same pitch as the T-slots on the mill. And the idea behind these is that I can put them on the mill like this and bolt them down, and I can support larger plates to work on larger plates so they're not drooping and hanging over the machine unsupported. But I can also use this is a pretty good piece of material here, so I can also use this as a fence. So what I'm going to do is I'm going to bolt it down at an angle here like this, a precise angle, reasonably precise I should say, and then use that as a fence against one of my datums on this. So let's go ahead and get that going. The first part of this is I want to just anchor this thing down, something like that. Okay, so now I got a pivot point there that I can juggle around there. Okay, something like that. Okay, so now what we want to do is we want to set a nice angle there. So I'm always advocating using sine bars, so we're going to go ahead and use a sine bar just because it's easy. Okay, I don't have to think about it too hard, and it's deadly accurate. So. Okay, so I got my big sine bar from my old toolmaker friend Fred Van Beber. I think I told you guys a story about this guy here. So what we're going to do is we're going to use that like that, and we'll use the front of the machine here as our reference surface. So the angle, so we got 120 degrees spacing between the roller guides. So off of this datum here, and this is where you can get messed up with angles, is what's your reference, right? So, we've got several good references. So if you've got X and Y, which are 90-degree coordinates, and then, and then we have our 120-degree reference, right? So, what's the angle, right? So it just depends what your reference is. So I don't get too hung up on that. I think about what I want to use as a reference, and then what's the angle in relation to that reference. And And since it's really easy to make mistakes and bozo it up, I use the dumbest tool I can possibly use initially. So let me grab that. So your good old protractor here, and I gotta grab my glasses. So I can see here that you know, this is approximately where I want that, and I can think about my reference in relation to 90 degrees, or I can think of it in relation to this other datum here, right? Which is what I want to do. So, and all this is just a double check that I'm on the right track here, okay? And that looks correct, and that's 30 degrees off of 0 or 180. Take your pick, right? So that's 30 or 150, right? Okay, so take the small angle. So we'll take the sine of 30 degrees and multiply it by the distance of this, which is a 5-inch sine bar, okay? And we get 2.5, okay? So once again, just the, you know, the bozo check here. This is sort of set. And I don't know, 2 5/8. Okay, so I can buy that, right? So I'll buy that for a nickel, right? All right, so let's get some 2.5-inch block. Okay, so what I got here is they're not gauge blocks, but these are Moore jig bore setup blocks made by the Moore Special Tool Company, and these are they're kind of an odd size, but I find them really handy. They're like 1.5 by 1.25 by 7/8 of all things. Anyway, these are like dead nuts. These guys just make some fantastic stuff. They might as well be gauge blocks, but they're just setup blocks. So what we're going to do is we're going to stack those up at the yeah, it's 1.25 direction. We're going to stack those up, and we're going to use our reference on the front of the machine here to set our angle. And I think I showed you guys these before. I have these little T-nuts in the front of the machine here that come in handy for this kind of junk. Okay, so now I got a good accurate fence there. I'll tighten it up in a sec. And we're gonna have one in there. Oh yeah. Alright, bastard. I had to pop that one out just so I could get onto it. Okay, so I need one under the heel of the sine block or the sine bar, and I need one under the block end. Okay, so that looks about right. And okay, so that seems about right. And you tighten a few things up. Snug that. Okay, so that's nice and parallel now. Pull my sine bar down against that, against the blocks. Okay. Blocks are tight. Oop, something's moving. Okay, so I got a little snug on that now. I don't want to bump anything. So I want more than one lockdown point here. So I'm going to put I'll put a toe clamp here. And now I got a nice fence. I can slide things around, and I got a decent reference. So I'm going to grab a toe clamp. And you want the bolt up nice and close to what you're clamping on. It's just good practice. And, okay, I don't know if you can see that, but I pushed on the front of the clamp and the heel came up. So you don't want that condition. You want the next notch up. Okay? So you never want the clamps this way. You want them dead flat or one notch up at the most, okay? And a lot of people really over tighten the shit out of these things. You know, the ones at work, they're bowed and they're pretty hammered. If you crank on that reasonably, you're developing, you know, thousands of pounds of clamping force. So you don't need to reef on those things. And you know, a couple of fingers and a foot here, that's pretty good. I don't know why people insist on whaling on those things. Okay, I'm checking my setup. I'm looking at my gap there. Okay, I'm pretty happy with that. Let's get the tools out of there. Double check that. Okay. All right, let's clear this out. Okay. Oop, those gotta come on. Little reference blocks. Oh yeah, I can just turn them. Good. I might need them again, so I'm gonna rotate them down out of the way. Okay, so now I got this nice fence at this angle here. Angle looks right. So now I'm parallel with the machine. So I'll pick up the center between here and start working that groove right there. So now I got to hold this to the machine, so I could clamp it here, I suppose. But this is my datum here, so I think what I'm going to do is I'm just going to toe clamp it down close to where I'm working, and call that good. And then I can flip this over for the next one, like so, and do that. And then for the opposite side, let's see, those are parallel. Yeah, I'm gonna have to change the bar and swap the bar around the other way to do the opposite side. So anyway, that's kind of the little setup we're gonna use here. No. Okay, well, I'll get this clamped down and get it all set up and do some milling there. Okay, so that's a 1-inch diameter cutter, and that was 300 deep, and I don't know what the feed rate was. That was I don't know, 3 inches a minute or something like that, maybe. 25 millimeter cutter, around 8 millimeters deep, and 260 RPM. It's one of those fine pitch cobalt roughers that I keep talking about. So we're gonna take another little bite here. Another 220 off of the side here. And come back the other way. I just increased the feed rate a little bit. So, let's see. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, 12,000, 13,000. So 13 seconds for an inch, something like that. You guys can do the math and figure that one out. Alright, so we finished these guide slots in the lower section of the steady rest here. So finished them on both sides there, and so now I need to poke a hole through and thread it for the adjustment screw. And these are at this weird, well, not weird, but it's they're at an angle. So I have to set this thing up so that I can drill this. Now this is where a horizontal spindle would come in really nice. You can just lay it on the table like this and poke away at it and go through it. But when you have a vertical machine like this, you gotta horse around a little bit. So so looking at it here, it's got this cutout, which is we can loop around the table here a little bit. So I think what we're going to do is we're going to kind of set it up like this, and then we have to drill and thread here, drill all the way through. But I got to hold it, so I think what I'm going to do is I'm going to set the vise up at 90 degrees like this, so that I can just drop the part in there and then indicate it straight and then work out of the vise. And then when I do the other side, just flip it around and grab it. It's pretty easy. So let's go ahead and we'll get the get the vise set up at 90 degrees somewhere right in that region there. It looks pretty good. And then what we'll do is we'll swing the head over here so that it's over the part. That's the nice thing about these types of machines is you can move the head all the way all over the place and get over this open space over on the side. So we'll get that set up. I'm going to grab some clamps. Let's do the side one here first. Alright, just gonna eyeball square that. And then I'm gonna put a couple toe clamps on the vise just to hold it. Probably doesn't need very much, but you know, certainly don't want it to move. It's not suboptimal. And I'll be indicating this here in a minute. Just kind of getting the basic clamps on it right now. Okay. All right. So now we need to do a little indicating here, get this straight with the world, and we'll nail that down, and then we'll get our part in there. All right. So we're gonna indicate this vise in here. So drop this down a little, like that. Little on the indicator, cross. All right, that's looking pretty good. Get these other clamps down a little bit. Excuse me. Alright, pretty happy with that. Okay, so now we can put our part in there. Let's grab that view. Well, this is the general idea right here. Like that. Uh-oh, what's going on there? Alrighty. The toe clamp is hitting the end of the vise there, or the threaded portion that comes out. With a little less grab on that one. Alrighty. That's better. That sucker's gonna be like that. I think I'm off the. Yeah, I think I'm gonna put it up on a consumable parallel there, like that. Just you know, you'd hate to drill into the bottom of your damn vise there. It's just the kind of thing that pisses you off, right? All right. That looks kind of straight. I'll be indicating this anyway, so just want to get a little tension on there. Alright, looks pretty good. Now we're going to swing this top over now. Boy, who tightened these up? Jesus. Oh, that must have been me. Actually, you know what? I don't know if... Yeah, alright. That. Bring it out a little bit too, just for ha-has. Just because it's easy. Alright, looks like we're in range there. One of my favorite stories is I was doing a job on a big plate, and I had to swing the head around like this, and I was machining the edge of the plate, and I was like, geez, why is my cut tapered, you know, like that? What the heck's going on? And I'd forgotten to tighten the turret bolts, and so as I was machining, the head was just pushing back out of the way, and it took me a little while to figure it out, but kind of embarrassing. But it's all right. It was cut into the small, so I was, you know, was able to recover without any problem. But so that's what I always tell everybody: when you move it, lock it down. Just lock it down immediately. That way you don't forget. Okay. So we're kind of right over it now. So I got to do. I think I'm just going to indicate this machined edge for vertical, and then pick up the center of that, and I'm going to call that. I'm going to call that pretty good. So, excuse me. I'm going to get a test indicator, and we'll do that. Okay, so what I'm going to do is I'm going to use a test indicator here, and I'm going to run up and down that edge to make sure this is all straight. But I know it's not very straight right now, and it's, you know, I just threw it in there. So what I'm going to do is I'm going to just use a square here, a solid square, just to kind of get it within the range of the indicator. You know, so that you're not trying to move a lot with the test indicator. Now I can see that it's off a little bit right now, what I'm going to do is use one of these adjustable parallels so that I can project that reference surface out a little bit, like so, and that wedge is in there nice, okay, and it's bearing on both sides nicely. So now I can put the square up against here and come up against that edge. Now, I got a little problem here with this square. It's got a thick base on it. This is an old Brown & Sharp 542 here with a beveled edge, but the body of this is pretty thick. Well, I have this other one that I got a long time ago, and this is a Mitutoyo here, and it's basically just a flat piece, a 1/4 inch, that's got some bevels. So that'll do the same thing, but it tucks in a little closer, and you can see that I'm out a little bit there. So very carefully here, I'm gonna try not to drop this on my foot. Well, let's use the longer wrench here. I'm just gonna crack this, and I'm just gonna bring it up. Well, it looks good. And I'm gonna lock it down. All right. So now we'll throw an indicator on it, and we'll see what the indicator says, and go from there. Something like that. Let's see the thing. I think I'm just going to take that out of there. Like that. So I should be easily within the range of the indicator now. Let's see what we got here. Run it up to 0. Alright. And, well, you know what? Sometimes you get lucky. Look at that. So, what is that? That's chicken feed right there. So, it's on 0 now. Make sure, yeah, it's bearing against there. So, okay, I gotta say that's pretty much luck. Yeah, sure, I looked at the square, but you know, it's not even moving a half thou. Okay, so let's say before we screw up again, let's lock that up. Okay, and that's near perfect. So that's what happens when you use a what I call a dumb tool first, right? The square is just a comparative tool, right? So it's just kind of, you know, eyeball centric, right? And but trust your eyes, you know. What happens is you get lucky more often than you don't. So I mean, sure, I could have just put the indicator on there right out of the gate, right? And stabbed away at it for 20 minutes and you know, tapped it around and farted around with it, you know. But by using that square, I had some reference that I could see and get close, and yeah, I did get close. And you know, it is luck, and but I think some golfer said the more I practice, the luckier I get. So I've always liked that saying, and it's something that I always think about. Okay, so we're nice and tight there. You know, I got a bit of weight hanging off here, so I want this pretty tight. So you know, if I bump it or something like that, I don't want it to shift, you know, halfway through. And I'll be putting some drilling pressure on this too. So all right, let's pick up the center of that Mamaluca. So I'm going to use this again here. Because what I care about is that I'm in the center of this groove, which is what is the number? You know what? I don't even care what the number is. What I care about is I'm in the middle of that, and for my the hole I'm going to put in. So I'm going to come down and I'll pick this up and find the center of that, and then I'll find the same thing in the center of the little boss that's left. So I'll change that around. Alright, for this one I want a chuck. I'm going to need a chuck pretty soon anyway. And alright, so what I'm going to do here, I'm going to use an indicator and the DRO to locate the center of this here. So I'm going to put this in neutral. Going to get that lined up. And I'm pretty sure you can see there. Okay. So I'm going to come over here, and the way this works is I'm going to sweep that surface is what I'm going to do. And I'm going to find the high point. Somewhere in there. Okay, I'm going to come up, touch off. So the indicator is not on center. Over there. Alright, that'll do it. Alright, so I'm looking for the high point there. So I just sweep it, and then I zero it. Okay, so now I'm on 0. I'm sweeping that, I'm finding the high point. So I'm going to zero the DRO. Okay. And then come off of the part. And I'll come over here. And I'll do the same thing on this side. Without touching the indicator, very gingerly. Okay, pretty good. So now I read my measurement right off of the DRO. So I got 1.8344. Okay, so half of that is the center of this thing. All right. All right. 1.8344. So what is it? 972. Okay. Seven, 2, okay, and I'll re-zero. All right, so now I don't need this anymore. Get that out of there. You know, I could do the same thing here, but I think I'm just gonna edge find that. That's easy enough to do there. So. Oh, gotta be kidding. Oh, you know what? There you go. So, alright, I gotta do all that over again. So I came up against the edge of the machine here. I ran out of travel. So that's a bozo mistake there. I should have checked that before. Alright, so well, when you get to bozo it, you get to fix it, right? So just need a little more room there. Alright. that out a little bit. Nice. Now I got some room. I got plenty of room. All right. Let's try that again. So, yeah, I could indicate, like I did again, I got a good edge here too that I can catch with the edge finder. So we're just going to do that because I already need the edge finder in there anyway. So, what the hey, right? All right, but I need to know the width of that groove though. And I want the width of the one I'm using. And I like this because it bears on more surface. I think I mentioned that before. So we'll get a micrometer. Actually, let's see, okay here. Well, it's a good number. That's what it's supposed to be. It's 1.5, like right on. Okay, so good. Makes the math easy, right? All right. We're getting there. Let's do this way first. So I just check that. Okay. Okay. All right. So let's measure that guy. That's 815. Oh, 7, 5. Okay. So theoretically that's the middle, theoretically that's the middle. Okay, so we're going to be drilling some holes now. Now this is just a spotting drill here. Actually, one of the viewers actually asked, I think I was using a center drill. It's probably just what I grabbed. These are generally better. So I'm just making a little dot there to look at it, make sure that it makes sense. Three-eighths plus, three-eighths plus. Well, that's 3/4 wide. Yes. Yeah. So that's just the bozo check there, in case I forgot to take off for the edge finder or something like that. I'm just going to get a nice spot there. That looks pretty good. Out of there. Okay, got to grab some tools and we'll drill the hole. Alright, so we got a 1732 drill here. We're at about 450 RPM, something like that. And I'm not going to put a pilot hole through it.